Good evening. Good evening, everyone. I hope everything is clear. Yeah. So once again, good evening to everyone. Welcome to the Agentic Intelligence Masterclass series. So today is a day 15. So today we will discuss about the multi-agent system, how they are communicate and coordinate with each other. So this is the way we can discuss about the today's session. Okay, last session you was discuss about the data exploring agent, right? How it was work, and as well as on summarizing agent, followed by that YouTube analyzer also was discussed. With the help of Mind Studio tool, you was see with the two different agents how it was worked. So most of people you understand, I think. So now we can forward by this. We can continue with that multi-agent system. So already we know single agent. That means one particular single agent to enough for that particular work. Some kind of works we need a one or two more different agents interact with them or work together in each to complete that one particular work. They both are involved in that particular action. That is the multi-agent system. So now I will explain how it was work and everything. So first, what are multi-agent systems? So the multi-agent system consists of multiple autonomous agents that interact within a shared environment. So each agent has its own goals and knowledge and capabilities, yet they collaborate to achieve the objectives beyond the individual reach. So these systems mirror natural phenomena like ant colonies or bird flocks and human organization, and where collective intelligence emerge from simple individual behavior. So try to understand what is there is it said exactly. So the multi-agent system, they have to work multiple agents at that time. So in the first time we was using one email sending agent, but in that particular place we are using the multiple tools, but agent is a single agent. The email sending agent, the single agent is there, but we are using the multiple tools in that particular process. Lindy A we are using, and Gmail we can connect with that. So one or two different tools we are using for that. The process has to be done. But the agent work is a single work. That is the single agent as well as multi-agent. How we can represent that means comparing to the natural nature. That means the ant colonies. You know, the ant group, they have to collect the food with every people. I mean every ants is going to the collect the each single. It's a small food. The every ants will going to and work together. And the birds also, they have to going to collect, or they have to migrate to one place to another place. They have to fly with that with their people and with their another bird. They make a group and they have to do the every work with a group of animals. Same like that here, the human also, we have to transport one big fragile or a big, what was that, big material, big product, means we have to make, we need a help to the another person also. So now I have to take one chair, means that was single, there's a less weight, the plastic chair or steel chair, anything is single chair, I can easily take that. The group of 5 to around 10 to 15 chairs means I need help. Same like that, one particular work, the single agent can't do that. We need to connect the another agent for their complete their work in easiest way or speed fastest way. That's why we have to using multi-agent in here. So core components of multi-agent system. Okay. First is autonomous environment is shared the space where agent operates the perceive and interact with each other. So already we were discussed, that is piece framework. That was followed by the performance, environment, actuator and sensor. That was a piece. Same like that here, environment is work based on the surroundings wise. They have to operate and think of that surroundings. Then they have to do that based on the surroundings wise. And the interaction protocols, that is rules and standards governing the how agents communicate and coordinate action. How one particular agent contact with another one, how they have to coordinate. You can do this work, I do this work. Like that way, how they have to separate the work and work together. That is the important thing. That is interaction protocol. And goals and objectives. So individual and collective targets that drive agent behavior and collaboration. So now I give another example for the interaction protocol. So as a one driving person, as a driver, he is know about that, right? So for example, one taxi will go onto the one particular road. So opposite the another vehicle is there. So here this taxi driver will pass that particular bridge. That was single way. The one way at the, one vehicle at the time they have to entering that particular road. So that time the opponent taxi driver to what was that? Give a what was that? Notification to the another person. So I have to cross this road. So kindly give a way. Like that, the light headlight will be flicker. They do that purposely. They have to do that flickering in that headlight on the headlight. That is one of the notification. I have to pass the road. So kindly give a way for me. Like that way, they have to intimate to the opponent driver. So same the format that autonomous vehicle or any another agent, they have to give an intimation to the another agent. I can take care of this work. You can follow this next one. You can do the another work. Like that way, they have to communicate with each together, and then they have to smoothly the particular work has to be done. So like this way, okay. Oh, sorry, I can't zoom the screen. Okay. Now it's clear. Okay. So now, so that was the interaction protocol. So like this way, every agent interact with them to communicate to the another agent. So goal and objectives, individual and collective target that drive agent behavior and collaboration of this is our major goal. So now is another key factors of the multi-agent system, that was autonomous agent, environment, coordination mechanism, communication protocol, and collective intelligence. So they have to miniature of this previous one. Sensing, decision making action, and environment share the space for interaction, and coordination mechanism is a task allocation and planning. Communication protocol is a message passing and signaling, and collective intelligence is a emergent group behavior. So next one is a coordination mechanism. First one, the coordination mechanism is a agent must coordinate to avoid the conflict, share the resources efficiently, and achieve the collective goals. Different mechanisms suit for the different scenarios. See, already was discussed this on this one also. So based on the feature, surroundings wise, the action was deferred. And centralized control, distribution coordination, and hybrid approaches. Centralized control means a master agent directs other and ensuring the consistent but creating a single point of failure. So everything we have to follow by our team lead. So every kind of action, the team leader is there. Team leader or manager or supervisor. So like that way, one head of people is there. The another people, the workers, they have to follow their comments and work that particular work, do that particular work. Same like here, the centralized control. In every one, multiple agents is there, but every agent, the one particular major or team agent, what was that? Leading agent will control the every sub agents. How the human brain will control our body, same like here. So it is one of group of the work, one of group of the agent type, like multi-agent type. Next one, distribution, the coordination. So agent negotiate and decide collectively, offering the robustness and scalability. So here they have to give a command. Command means the centralized control means they have to how we can say okay. they have to already start that particular work, that is centralized control. They have to begin the particular work, followed by that the sub agent will be complete that particular action. Same like that here, distribution coordination means just we can follow, provide the command or provide the plannings, then the another sub agents to take that command wise, they have to initialize the work. That is the distribution coordination. Hybrid approaches is followed by that, combines the centralized oversight with the distributed decision making for optimal flexibility. Combine centralized oversight with the distribution. It was both thing they have to contains. How now MNC companies provided the hybrid work. Hybrid means 3 days they have to work in office, 3 days you work from home, 2 days is a leave. So like that way, here also hybrid approach will be that they followed by the previous two things, that is centralized as well as distribution concept. Combine with then centralized sub agents with the distributed decision to follow, you can do this work like that way. And then communication strategies, how they have to communicate each other. So low overhead and high overhead, like two things is there, and tight coordination and loose coordination. So the first one, the direct messaging, low overhead and loose coordination. So each thing is having that different work. So direct message means the overhead, that means they are not give a training. That means training means they are not show any example you can do like that. Just like that you have to say it, I need a output like this, you can do that work like that way, like how we can say it. They not give a syllabus, but they have to say it, you can train with yourself, like that way they have to say it. That is, in that particular direct messaging they follow facing the issue of low overhead and loose coordination also. The broadcast protocols is a high overhead and loose coordination. It's near, it's similar to the direct messaging, but it was getting to the high overhead. High overhead means the most of the people to prefer that. And contract net means moderate overhead and a tight coordination. Contract net means you have done this one, I can give you the I have pay you like this amount, or I have to do a favor for this, like that way they have to set the contract net. Blackboard system means low overhead and a tight coordination. Blackboard means they have to give a pre training. Before that they are doing one work, they have to give an example, explanation about that work. So you have to follow the steps, you can get the output like this. If you, in case you can facing any errors, you can follow these steps to resolve that. Like that way they give a entire explanation. It was easy to, the sub agent will be follow that commands and do that work. That was easiest one. That's why we can do that low overhead and a tight coordination. Okay, so this is the difference between these four strategies, communication strategies. And then effective communication is a backbone of multi-agent system, and agent exchanges the information through the various protocols and balancing the efficiency with the completeness to maintain the system performance. Next one, real world application. So there are autonomous vehicle, already I said autonomous vehicle, smart warehouse, drone swarm, smart grid, everything followed by the real world application of multi-agents. Why we can represent the autonomous vehicle here means the self-driving car coordinate to optimize the traffic flow, avoid collision and share the road condition in real time. They are depending on their another smart features, like weather condition means they are depending on the weather application. The another agent will be initiate the one particular autonomous car also. So they have to drive smoothly means they need information from the real time. They need real time information from the other people. So that's why. Smart warehouse means the robot fleets the collaborate to pick, pack and transport goods and efficiently across the massive distribution centers. Smart warehouse, the robots to loading unloading process, the robot can do that. That is smart warehouse. So same robot as a human, he is no just a minute. Okay, as a human he is know that, So one person will take that one what was that one package. I have to choose by the another one like that way. But the machine, they have to know. The machine also have to know. Then only they have to work like a human. So they need to understand the particular concept. One robot will touch the one particular product means I have to choose another one like that way. That is smart warehouse. And a drone swarms means the multiple drones work together for search and rescue, agriculture monitoring, and delivery servers. So you in most common and familiar one means everyone we can see the drone show. So the drone will be reflect. The drones are reflecting the shapes of animals or human face or letters way. That is drone show everyone we can watch, right? How they are work. They have to connect every drones in a single device. They have to give a shape wise. They have to detect that particular shape with a micro wireless communication device. They have to change the orders in one by one, like a smiley face or a heart in space, a shape, and then the butterfly shape. So everywhere. So most of the people we watch, we will see the drone show in our college time and any public event. We also see that. So in that place, each drone they have to know that know their position. In this particular shape means we have to one particular drone they have to represent the one position. Any one drone to change their position, that was collapsed to the every shape of the particular drone show. So that's why. Okay, so next one, smart grids. So distribution the energy system, balance supply and demand through the coordinated agent based on the control mechanism. That was the real world applications of multi-agents. And next, coordination example, task allocation. So task announcement, bid submission, winner selection, and execution and monitoring. So task announcement is central system broadcast available task with the location, priorities, and deadline to the all robots. We can take the autonomous vehicle like the Tesla car. So we have to give a task. You have to drive here to 1 kilometer. So that is our task. So you have to determine based on the weather condition wise. You have to do that every signals. Okay. So this is our task. So in that place, the every agent has to be work. The car is one of the agent. Followed by that, the communication device, the navigation, the map application, the navigation also one of the agent. They have to give a what was that? Navigate the route to the destination. Then only the car can drive and follow the same same route. Same like that, the weather condition. The another app will be helps to determine the weather condition. So every agents they have to work together. Then only they have to achieve their task. So next one is a bit submission. That is each robot calculates its cost and a distance, battery, current load and submits bits for the preferred task. So based on the task wise, they have to analyze is a self-analysis. How much distance is there? With the help of the navigation, like Google Map wise, they have to analyze the distance between our destination and the battery. They have to asking to their car device wise how much fuel is there. Fuel range wise, we have to increase the speed or decrease that. Current load, how much load we can get. So based on it was affected to our speed. So like this way we have to follow by the bit submission. So each thing they have to follow that each work. And winner selection. So system evaluates the bits based on the efficiency metrics and assign the task to minimize the total completion time. So we have initiated the one task, how much time they have to take. So which agent they are not do their work in that particular place. So we have to monitor that and we have to resolve the error in that particular one. Then execution and monitoring. So robot execute, assign the task while continuously sharing the status, update for dynamic reallocation if needed. So just now I said we have to monitor the errors and monitoring the mistakes. We have to resolve that. Then only it helps to make proper work in that particular agent wise. And what are the key challenges in a multi-agent system? Scalability, conflict resolution, partial observability, and agent may have completing dynamic environment, scalability, conflict resolution, partial observability, and dynamic environment. Scalability is represent to the number of the agents grow and communicate overhead and coordinate, and complexity increase exponentially, requiring the efficient protocol. Conflict resolution is the agent may have completing goals or resource needs demanding the sophisticated negotiation and arbitration mechanism. Partial observability is agent often lack of complete environmental knowledge and making coordination under the uncertainty a critical challenge. Dynamic environment is a rapidly changing the conditions require the adaptive strategies and real-time replanning capability from all agents. So scalability means what is our capacity, how much we can take and we can do. And conflict resolution, at the time how many tasks we can contain and how many we can complete that based on the timing wise. Partial observability means they have to observe some kind of flaws in that particular task. They have to remediate to that. My limit is like this, I can make that task in that particular range, I can't do the exhausted one like that way. We have to initiate that. Then dynamic environments, changing the conditions require adaptivity strategies and real-time replanning capabilities wise the all agent is to work together. That is the dynamic environment based, they have to compress their limit. Then multi-agent system architecture. So overall architecture, action layer, perception layer, and reasoning layer. So actually starts from the perception layer here. So perception layer is a subset of reasoning layer. The action layer is a subset of perception and reasoning layer. So this is the major one. This both are comes under this action layer. Perception means sensor and data collection for environment awareness. Reasoning layer is decision making, planning, and coordination logic. Action layer is execution, control, and actuator commands. So first they have to sensing their work, then they have to make a decision what kind of way we have to deliver to that. Finally they have to did that particular work, that is action layer. This is the way the MAS, multi-agent system architecture will be working like this. The future of multi-agent system, that is market size of the multi-agent, how they have to money they have to take. Market size by 2030, the $27 billion they have to invest to the multi-agent system. And the global multi-agent system market projected the growth driven by the AI and automation adoption. And efficiency gains mean 85% efficiency. Organizations report significant operational improvement, and through coordination agent system they have to take a 85% efficiency gain and 3% faster than the problem solving. So multi-agent approach solve the complex task 3 times faster than the single agent. So everything this concept already we know. One particular work, one person will take too much time means the 3 or 4% they have to complete that particular work. Comparatively it's take a less time to complete the one particular work. So already we know this kind of formula, right? So it's also applicable for machines also. This is our multi-agent system, we can follow it here. Okay, now I have to show you the example for, example means one right up I have to show one explanation, then we have to wind up this session. This is just a theoretical way. So what we can discuss now. In upcoming session we can try to see the example for the multi-agents in upcoming sessions one by one. Okay, so now I have to show you now I have to open the whiteboard. The whiteboard wise we have to easily write up that what we have to try to say. Okay, now I have to show you that okay. So now it's a one single agent is there. It was complete the one work to it take a time as a 1 hour. 1 hour to take a time to complete that one particular work or task. Same thing, the multiple one, 3 agents, 1 or 2 agents, they have to take less time to complete that work. So one agent, so second agent, so 3 agents is do that one particular work. How much time is take to complete that particular task? So we can split in the 1 hour into the 3 hours. So per person, per agent is take a time. We can contain like a 20 minutes, right? 20, all right, 20 minutes. So each agent take a 20 minutes, means they have to complete their work in 20 minutes. So we are saving their so we are saving the 40 minutes to save in this particular work completion. Same concept will be followed here also. So it's a simple concept, already you know that. Just understanding only, I have to share this. Okay. So now I will share the attendance link. So just a minute. Okay, I already shared the attendance link in a chat box and it was available in a pinned comment. Oh, scribbling pad. Okay, next time I try this one. Sumati, thanks for suggestion. So next time I try to that. Try to the scribbling pad. Okay, so now we can understand. I think theoretical part only you have discussed now how the multi-agent has been work. Okay, so next class we was discuss about the with the example of multi-agent and multiple single agent, how to create. As usual, we can follow by that one by one. How it was a helpful, how I can create that. So today just the theoretical part only was discussed. Already last session I was said to this. So next 2 sessions we was discuss about the theoretical part only. So our agenda is there. Every classes in description agenda it's available. So kindly check it that. I think day 17 we can enter into the RAG model, discuss about the RAG model. After that we are fully entering into the hands-on only. Okay, so thank you so much. So today we are discuss about the multi-agent system, mass multi-agent system, how they communicate and coordinate each other. We have discussed now. So next session, tomorrow session, we followed by that how to take a responsible for their work, as well as just a minute. Oops. So fully discuss about the what is the bias is there and what are the responsible for each agent. That was discussed in day 17. We are going to the RAG model and then observability one by one. So embedding the custom tools and each agent wise we are discuss one by one. Okay, I hope everyone can understand. So thank you all. Thank you so much. We'll meet on next session. So don't forget to give it your attendance. So it was available in the chat box and pinned a comment. So kindly check it that. I'm sorry for this. It's a theoretical session that only we can wind up before 6:45. Our timing 6 to 7. So every session we have to try to take a 6:45 or 6:40 like that time we have to take for each session. Today is a theoretical part only, so that's why we can wind up early. That's why. Okay, thank you all. Thank you for your coming and your listening. We'll meet on next session and see you all.